The last thing I'd like to do before we actually dive into coding one up in the next video is explain why these are used. And really the way that we order them, where everything to the right is greater than the parent and everything to the left is less than the parent, makes it very easy. It makes it fast to look things up. Also, it makes it easy to insert things, to find a place for a node. So that search part of the binary search tree becomes very quick compared to looking for a node in an unsorted tree. So let me show you how it works. Imagine we have this tree and we're looking for the number 72. All that we have to start is the root. So we don't actually see, like our code doesn't know what's lying ahead. It just sees the root. All that we have to do is check, all right, is 72 greater than 41? Yes. So we only care about this half of the tree. Basically, every comparison we do should roughly chop in half the number of values we look at. If you remember how binary search worked in a list, it's the same idea, where we have this data sorted, where everything to the right is greater, everything to the left is smaller or less than, and we make a comparison. Ideally, we chop the tree in half. Now, it depends on how the tree is distributed. We could have way more values over here and very few small values, but in general, on average, we cut the number of comparisons or the number of nodes in half. So we check. 72 is greater than 41, so we only care about this side. So then we go to 65. Is 72 less than or greater than? It's greater than 65, so we go over here. Now we get to 91. Is 72 less than or greater than 91? It's less than, and we found it. Now, if you compare that to if this was an unsorted tree and 72 was indeed in the tree, it could be anywhere in this tree, and we might have to look at every single node and traverse the entire tree. And we'll talk about how you would do that. But, you could pick any order. Do you go all the way here first, and then here, and then here, and then down here? Do you go to the right first? There's a million ways. Well, there's not a million, but there's many ways of traversing a tree. But with a binary search tree, when we're looking for a value, there's a very specific procedure we follow. We compare, and we go to the right or the left. We compare again, and we cut it in half. Keep going until you find the value or you don't find it. But because the way a binary search tree works, that value is not in there if you don't find it. Okay, so to recap here, there's many types of trees. There are binary trees where each parent or each node can have at most 2 children. There are many types of binary trees, one of which is the binary search tree. A binary search tree works for sorted data or sortable data, where there's an order. You can compare things. And it's the same rule as a binary tree. Every parent node has at most 2 children. But on top of that, every node to the left of a parent is always less than the parent. Every node to the right is always greater than the parent. And that makes it so that we can search, we can find things much faster.